Welcome back to the Deep Dive. If you're a first or second year apprentice in the Canadian Masonry trade, you know that right now, every single dollar you spend on tools, it feels heavy.
It does.
And every technique you're learning, it feels like it's setting in concrete. You're investing in your future.
You really are.
But trust us, the core hand tools you pick up today are going to become literal extensions of your arm over the next 40 years. They'll determine your speed, your efficiency, and critically, your physical longevity in this trade.
That's absolutely right. I mean, you need reliable gear that stands up to Canadian seasons.
For sure.
Gear that handles the brutal workload of commercial sites and, protects your body from that repetitive strain. But even more than the gear itself, you need to understand the science and the why behind the tools. Why one trowel shape gives you an edge in block work, or why a certain joint profile is non-negotiable up here, where the freeze-thaw cycles are just relentless.
That right there is the mission today.
Let's do it.
Welcome to the Canadian Masonry Podcast. We're laying the foundation for your career, one course at a time.
This deep dive is custom-tailored for you, the Apprentice's arsenal.
We're talking about the core hand tools that define our trade, mastering lines and levels in a high-lift environment, and that absolutely crucial final step, the art of the finish.
Yeah, we're going to discuss the strategic selection of the right trowel, analyzing how you can minimize stress while maximizing your load capacity.
We'll cover ensuring vertical and horizontal perfection, using the ancient wisdom of the story pole alongside all the necessary modern techniques.
And we are going deep into the technical details of the mortar, or the mud. We're focusing on the critical timing of the strike and what makes a joint truly weather-resistant.
Right.
This is where you separate yourself from the rookies and, start building a professional reputation.
Okay, let's kick off with segment 1, the tool belt deep dive. You said the trowel is an extension of the mason's arm.
It is.
And that relationship isn't just about movement. It's about ergonomics and geometry. When we talk trowels, quality steel, sturdy handles, and proper blade flexibility, they're non-negotiable for speed, ease, and most importantly, preventing that chronic wrist strain.
It truly is about career longevity. It really is. If you start your apprenticeship with some cheap, poorly balanced trowel, you are actively inviting pain and the early retirement.
So what's the first choice an apprentice has to make? Material.
Material, absolutely. You've got stainless steel, which is rust resistant. That means less immediate maintenance required on site, a definite plus in high humidity or rain.
But there's a trade-off.
Always. Stainless often means a heavier, sometimes stiffer blade, which can limit the feel that masons rely on for spreading and cutting mud smoothly.
And on the other side of that coin, you've got the forged carbon steel.
All right. That's lighter, generally offers better flexibility in spring, but it comes with a high maintenance cost.
What do you mean by that?
Well, carbon steel provides better feedback, and it's often preferred by brick masons for that springiness.
Right.
But if you don't clean and dry it rigorously at the end of every single shift, especially in our damp Canadian climate, it'll rust.
Fast.
And that rust not only degrades the tool, but it can actually stain light-colored mortar if you're not careful.
Yeah.
This leads to a really important point about construction. That blade, it should ideally be made from a single sheet of metal, forged right into the tang.
Why is that single sheet construction so critical? What's the failure mode you see most often with the cheaper welded blades?
Well, the problem with cheaper trowels is almost always a poorly welded tang. That's the piece connecting the blade to the handle.
Okay.
A weak weld, or some kind of composite construction, it introduces stress risers. And over years of hard use prying, cutting, constant vibration, that weld fails.
It just snaps.
It snaps, often right where the blade meets the shank. A solid, forged tang minimizes that vibration transfer to your hand and eliminates that critical point of weakness. It ensures the tool lasts decades, not months.
That difference in quality, it's directly related to the intense workload we put these things through.
Okay, so let's get into the geometry because the shape matters immensely.
There really does.
Which brings us to the classic rivalry, London versus Philadelphia.
Yeah, and they're built for different jobs, different units, and definitely different volumes of mud.
Okay, break down the Phillies for us.
The Philadelphia pattern is characterized by its signature, wider, flatter heel. That wide base lets you scoop and carry significantly more mortar on the blade.
So it's the workhorse.
It's the workhorse. It's the tool of choice for heavy-duty work. That extra capacity makes it fantastic for block work or laying larger, heavier stone units where efficiency in handling large volumes of mud is key.
But you still get precision.
Oh yeah, its pointed tip still offers the necessary precision for accurate placement and cutting, but its strength is really in the volume it moves. So if I'm on a site and I'm laying 8-inch concrete block all day, I want the Philadelphia pattern for that volume and stability.
Absolutely. Then you've got the London pattern. This is the classic historical bricklaying trowel, especially popular here for residential and commercial brick.
And it looks different.
It does. It features a sharply angled heel. That angle is designed to help push the mortar further down the blade when you're scooping.
Oh.
So it allows the mason to drop the mud precisely without using excessive wrist action. You'll find the London pattern in narrow and wide versions.
What's the difference there?
The wide London has a broader heel for scooping more mortar, for efficiency, but it's inherently heavier. The narrow London is typically the preferred choice for detailed or finer work on smaller units. It offers the best balance and the lowest weight.
The choice really boils down to the job and your body. That point about wrist strain is so critical.
It is.
I was reading a study related to WSI findings in Ontario, and it showed that masons suffer 1.7 times more musculoskeletal injuries to their arms and hands compared to other construction trades.
1.7 times. That statistic should drive every apprentice to choose gear based on ergonomics, not just on the price tag.
For sure.
The study by the Construction Safety Association of Ontario provided some excellent guidelines on sizing. They found that for bricklaying, an 11-inch trowel is highly efficient.
11 inches. Interesting. Not 10.
Well, it minimizes wrist stress compared to the smaller, often preferred 10-inch sizes, while performing just as well in terms of spreading time as the even larger 12-inch models. That 11-inch length provides the optimal weight balance for repetitive motion.
So if you're mainly doing standard brick in your first few years, that 11-inch London Marrow is probably the sweet spot.
Exactly. Maximizes your reach without excessive weight. However, when you jump over to blockwork or heavier stone, that's where the 12-inch Philadelphia pattern performs significantly better. The increased material volume offsets the slightly higher weight, and it makes the work more efficient overall.
And what about the handle itself? Wood is traditional, it looks great, but if it gets wet or covered in mud,
It demands a firmer, almost claw-like grip just to maintain control.
which is pure strain.
You nailed the failure mode of wood.
Hmm.
Slipperiness equals a firmer, high-tension grip. That drastically increases the strain on the flexor tendons in your forearm and your wrist.
So what are the alternatives? Rubber?
Rubber and leather handles. They offer great comfort initially and absorb some vibration, but they also absorb water quickly.
So they wear out faster?
They wear out faster and need more frequent replacement. The crucial ergonomic takeaway here is the angle.
The angle of the handle.
Yes. Always choose an angle that lets you keep your wrist as straight as possible while working. If the angle of the handle is too steep or too flat relative to your working height, you force your wrist into unnecessary flexion or extension.
And you're just inviting the very injuries we're trying to avoid.
Precisely. And if your handle angle feels wrong, the immediate fix isn't always to buy a new trowel. Sometimes it's just raising or lowering your scaffolding platform to change your angle of attack.
Right, keep that line straight from your elbow right down to the blade. Now let's talk trowel functions, the technical lingo that separates the apprentice who knows their stuff from the one who doesn't.
Okay.
We use the trowel to spread the mortar, which we call stringing the mortar.
Stringing is laying out that long bed of mortar on the previous course. But after you string, you absolutely must furrow.
Which is using the point of the trowel to make a trench.
Exactly. You use the point or the toe of the trowel to create a long, narrow trench right down the middle of the strung mortar bed.
Why do we furrow? Is it just about reducing weight, or is there a structural reason for creating that trench down the middle?
Oh, it's primarily about consistency, suction, and bond strength.
Yeah.
If you place a unit on a flat, thick bed of mortar, you risk trapping air, and the unit sits on high points unevenly. By furrowing, you ensure a uniform depth, and you allow the weight of the unit and the pressure you apply when setting it to distribute the mud evenly across the entire bearing surface.
So it facilitates suction.
It facilitates suction. The brick draws the moisture out of the mud, and it ensures full, consistent bearing beneath the unit. You also want that point or toe to be sharp because it's your primary tool for cutting off and keeping the wall face clean, scraping off any mortar smears before they set and harden.
And you have to master handling the excess mud. If you leave it on the board, it starts to set. If you drop it on the ground, it's waste. We talk about cradling and dropping mortar.
Right. Cradling is key to waste reduction and speed.
Mm.
As you set the unit, the excess mortar gets squeezed out.
Mm-hmm.
You use the edge of your blade with a sweeping motion to cut off that excess mortar and immediately catch it on the trowel.
So it's ready to reuse.
It's ready to reuse on the next unit or to drop back on the mortar board. It's a fundamental move that keeps the site clean and minimizes costly material loss. Dropping is simply allowing the mortar on the blade to fall gently and precisely onto the surface of the unit you're placing.
So mastering those movements, the stringing, furrowing, cradling, and dropping, that's what makes you fast, clean, and efficient.
That's the whole game.
Before we move on, we have to discuss the hammers. Because while the trowel handles the soft stuff, the hammer, it handles the hard stuff.
The inevitable reshaping and cutting of units that don't fit the gauge.
Exactly.
Indeed. The brick hammer, or mason's hammer, is indispensable. It's dual purpose. You've got the flat face, which you use for gently tapping and setting the unit into the bed joint, making sure it's fully seated and aligned.
And the other end.
Then there's the critical chisel end, the chisel peen, which is designed for quick cutting and shaping. You use the peen to chip away excess material, or after you score a line on a unit, you can use a sharp blow to split the brick cleanly.
And then there's the powerhouse tool you use when the brick hammer just doesn't have the mass.
The mash hammer.
The mash hammer.
Or a lump hammer. It's a small, heavy sledgehammer. Apprentices need to understand its specific function. You never strike the masonry unit directly with it.
Right. That's a key point.
It's used exclusively for striking chisels, like a brick set, a bolster, or a pitching chisel. It provides that necessary heavy, controlled impact to make those deep, precise cuts, especially when you're facing or splitting natural stone.
So if you're using a carbide-tipped pitching chisel to face granite or limestone,
You'll be using a mash hammer to drive it home, for sure.
And speaking of granite, I have to stop us right here.
Oh no, here it comes.
You know, being a stonemason is actually a very sedimentary lifestyle.
Uh-huh.
Until you actually have to lift the granite, then it's just a hard way to make a living.
That was rough, but accurate enough. The point about the material itself is important, though. Those carbide tips are often preferred for cutting stone because they retain their sharpness and strength way longer than standard steel.
Even though they cost more up front.
Right. It's an investment that pays off in reduced chipping time, greater precision, or just fewer necessary replacements.
Okay, that takes us neatly into segment 2. Measuring, line, and vertical control. We just talked about hand tools, but those tools rely entirely on consistent, precise layout.
They do.
You can't be pulling a standard tape measure every single course to ensure you hit the elevation marks. That's where consistency tools like the story pole come in.
Absolute consistency is the foundation of quality masonry. The story pole guarantees repeatable results. It minimizes human error during repetitive layout tasks across a large footprint.
It's a simple concept, really.
It's simple but brilliant. A long, straight piece of rigid material wood, aluminum, sometimes a metal stud marked with all your critical vertical measurements.
So we're talking course heights, obviously, but also things like windowsill heights, door header locations, anchor positions.
Exactly. It's the master key for the vertical plane. Its primary function is transferring those vertical measurements quickly and consistently across various points of the framework.
Especially on corners.
Especially when setting up corners or leads that might be 100 feet apart. You mark it once accurately, often using a laser level to establish your first benchmark, and then you use the pole to replicate that exact accuracy everywhere else.
It's crucial in multi-story construction.
Absolutely. It ensures uniformity across the entire structure before you even lay a single brick.
And to complement that high-level vertical consistency, we use the gauge tape. This isn't your standard tape measure, is it?
No, it's highly specialized for our trade. A bricklayer's gauge tape is specifically marked in preset increments that are tailored to gauge standard brick courses.
So it takes the math out of it.
It simplifies the math dramatically, especially when you're dealing with imperial or metric units that don't always align with whole numbers. If you know the desired overall height of a wall section and the number of courses, the gauge tape instantly helps you determine the ideal average mortar joint width needed to achieve that height perfectly.
And that avoids those cumulative errors that could leave your last course too narrow or too wide.
Precisely.
Okay, so once the vertical layout is established with the story pole, the fundamentals of the trade kick in. Levels and plumb. The standard mason's level on a commercial site is typically 1,200 millimeters or 1.2 meters, but you always need shorter torpedo or box levels for checking tight spots.
Like narrow window openings or lintel bearings, yeah. And the level is never more critical than when you're building a corner, what we call a lead.
A lead.
A mason has to check 3 critical things using that level every few courses. This is the triple check that determines the wall's integrity.
What are the 3?
First, is the surface of the new course truly level horizontally? You read the middle vial for that.
Oh.
Second, is the corner vertically plumb? You check the outer vials to confirm the corner isn't leaning in or out.
And third,
Is the wall face straight and flush? You lay the level right against the wall face to ensure all units sit flush, confirming there's no bowing, no sinking, no bellies in the wall.
that's the rhythm of the lead. Lay a course, triple check. Lay a course, triple check. You mentioned the importance of that air bubble, and I have to interject here with a story.
I think I know where this is going, but go ahead.
I once worked with an apprentice who tried to return a spirit level to the hardware store because he said the bubble was broken.
No.
Yes, he spent 20 minutes trying to find refill bubbles in the plumbing aisle.
That perfectly illustrates the need for fundamental training. It's that controlled airspace in the vial that guides your entire trade. But seriously, speaking of guides, let's talk about the mason's line.
Right. The traditional essential reference for horizontal control, the line, usually a braided nylon or polyethylene, is what keeps those horizontal courses straight and aligned. It guarantees a consistent height and makes the wall look right.
And to secure it, we rely on line blocks and line pins.
Like those down.
Line blocks, usually solid wood or sometimes molded plastic, are the common attachment for outside corners. They just wrap around the unit and tighten the line. Line pins are specialized metal tools used for securing the line at ends or inside corners.
And you just drive them into a joint.
You drive them into a head joint at a 45-degree angle to hold the tension. And that tension, it has to be considerable to prevent sag, especially on long runs.
And because that line is under such high tension, we have a serious safety alert here.
Yes, that line is a loaded spring. An accidentally dislodged block or pin from a misplaced unit, a slip, vibration, it can snap back with considerable force.
And cause serious injury.
Lacerations, eye injury for sure. We stress the importance of attaching the excess line at both ends in a separate secondary tie-off after you tension it.
So if the pin or block slips,
The excess line acts as a tether. It stops that high-velocity recoil. We also use small metal wedges called twigs or tingles placed between the line and the course to prevent sagging on longer lines, ensuring the line maintains perfect alignment right across the wall.
now, let's connect this work to the elevated structures you often see in commercial Canadian construction, the high lift context.
Right.
How do these tools and techniques scale up?
Well, the fundamental principle level in Plumb, that never changes.
Right.
But the way you access the work and move materials does. We rely primarily on frame scaffolds, the most common system, built of braced steel or aluminum frames
And the mason works from platforms.
from heavy-duty platforms, often supported by outrigger brackets secured to the scaffolding standards. The key here, and this is why those WSI studies are so important, is posture and efficiency.
You have to brazen the platform.
You have to. Those working platforms must be raised frequently, sometimes every 4 to 6 courses. So the mason is always laying material between knee and chest height. This comfortable posture prevents excessive bending and reaching, and it directly reduces back and shoulder strain.
Moving the actual heavy materials, the units in the mud, is another challenge at scale, especially once you pass the second floor.
Absolutely. I mean, moving units and mortar boxes on the ground floor is often handled by a simple pallet jack or maybe a powered mortar buggy.
A little self-propelled container.
Right. But once you go high, we shift to specialized hoisting equipment and delivery systems. For the units, we use forklifts or cranes to hoist full pallets to the highest accessible platform. For the mortar, the logistics are a bit more complex.
Let's detail that, especially for large, high-volume jobs that require grout-like filling reinforced cavities in block work.
Yeah, when dealing with grout specifically, which is much wetter than typical mortar, we use gravity-based grout delivery systems for high elevations.
How does that work?
So the mixed grout is prepared in a large, heavy-duty hopper on the ground. That hopper is then sealed and lifted by a forklift or a tower crane to the required elevation.
And then you just pour it in.
Once it's positioned safely on the scaffold platform, the grout is carefully released through a chute or a tube that directs the flow right into the masonry cavity.
That requires maintaining incredibly strict consistency in the grout mixture.
Oh, precisely. To ensure it flows properly but doesn't segregate under pressure.
Segregate.
Yeah, if the grout is too wet, the aggregates can separate from the cement and water before it reaches the bottom of the cavity.
And that compromises the strength.
Completely. Which is why we test the slump religiously, and we'll get to that. The safety aspect of high lift work is just enormous, too. Everything needs to be secured, especially the tiebacks connecting the scaffold to the building structure. The margin for error is 0 when you're 20 stories up.
Okay, let's move to segment 3. The moment of truth, jointing and striking. We've laid the wall, we've buttered the vertical joints, the courses are plumb and straight, the units are set. Now we apply the art and the science of the finish.
This is the critical transition, from structural work to finishing. I can't stress this enough to you apprentices. This is the last thing the mason does, but it's the first thing the client sees.
And the single most important factor for long-term weather resistance.
That's it. You can lay the straightest wall in Canada, perfectly level and plumb, but if your striking is sloppy or inconsistent, the whole job looks amateur. And worse, it will fail prematurely.
Don't let your finish ruin your frame.
Exactly.
So let's nail down the prerequisites for those mortar joints. What are we aiming for in terms of size according to Canadian standards?
Consistency is paramount. Typical joint width, according to CSA standards, should be 10 millimeters, generally falling between a 7 millimeter minimum and a 13 millimeter maximum.
And you can't cheat.
No, varying your joint width to correct course height errors is poor practice. That should have been managed by your gauge tape and your story pole. And structurally, a non-negotiable rule is that your vertical joints, the head joints or perps, must be fully filled with mortar.
And we absolutely forbid what we call slushing.
Correct. Slushing, that dangerous, lazy practice of trying to fill the head joint by dropping excess mortar from the top of the unit after it's been placed, is strictly prohibited.
Why is it so bad?
Because it guarantees voids and air pockets, which compromises wall integrity of weather resistance. A properly built wall requires you to butter those perp ends properly before you lay the next unit. That ensures full mortar coverage on the vertical face.
The entire outcome, especially the durability and color uniformity of that joint, hinges on timing.
It's all about timing.
You can't strike too early or too late. This brings us to the technical focus. Thumbprint hardness.
This timing is the single most important and often the most missed lesson in finishing. Thumbprint hardness is the precise state of mortar set where you can press your thumb into the joint, see a definite print, but the mortar absolutely does not stick to your thumb.
And when does that happen?
It usually happens between 30 and 90 minutes after laying, and it depends entirely on temperature and humidity.
Let's talk about the physics of that moment. Why is that specific timing so important chemically?
It all relates to the hydration process and the management of water. When the mortar is too wet, so before thumbprint hardness, it's saturated with bleed water.
Right.
If you strike too early, the pressure you apply forces that excess water out, and it disrupts the capillary system within the mortar matrix. It can cause microscopic fracturing and weaken the bond.
And you'll smear the brick.
You'll smear the face of the unit. Conversely, if you strike too late, the mortar has started to crystallize and lose its plasticity. You cannot achieve the necessary compression to seal the joint effectively.
So you're left with a permeable, unsealed surface.
And that's a highway for moisture penetration.
And consistency during this phase is paramount because uneven compaction of the mortar leads to a huge problem later on.
Oh, differential weathering and color variations. A huge problem.
Explain that.
If a mason strikes one section at the ideal thumbprint hardness, they compact and finish the surface well. If the adjacent section is struck too wet, the resulting joint will have a different density, a different curing process, and a different surface texture.
And over time.
Over time, these two sections will absorb moisture and weather differently, leading to noticeable color differences, sometimes a mottled or blotchy appearance, which ruins the aesthetic uniformity of the wall. Consistency in timing means consistency in appearance and performance.
Okay, let's talk profiles. The joint isn't just aesthetic, it's a physical weather shield, especially critical here in Canada.
The goal of tooling is compression and sealing.
So which profiles provide the best, most practical weather resistance?
The standard, highest performing choice in modern exposed masonry is the concave joint. You make it using a convex or rounded jointing iron.
Sometimes called a sled runner.
A sled runner for the long bed joints, yeah. It offers excellent weather resistance, and it's the industry standard for exterior walls.
How does it work?
It works by deeply compressing the mortar and sealing the edge of the unit face. The resulting curved depression ensures water can't sit on the joint surface. Gravity and surface tension pull the moisture right off, protecting the wall structure.
And the other strong contender for high weather resistance.
The V-joint, which you form with a V-jointer. This also provides very good weather resistance because the sharp angle efficiently and rapidly guides moisture away from the joint faces, kind of like how a roof peak sheds water.
So the concave is the workhorse.
And the V-joint is often chosen for a slightly more defined architectural shadow line that adds definition to the coursework.
And now for the mandatory warning, the raked joint. It looks great, it's modern, but functionally, in our climate,
It is a liability. It's popular because it provides a very neat, crisp, recessed shadow line, often achieved using a joint raker or a wheeled raker. But this profile is universally categorized as not weather-resistant and should be strictly avoided in any exterior wall exposed to the elements, particularly in Canada, where we face severe freeze-thaw cycles.
Let's elaborate on why it fails, because this is a key apprentice education point.
Yeah.
Why does raking lead to failure?
Well, raking simply removes the mortar to a set depth, usually about 5 to 6 millimeter deep. But crucially, it does not fully compress and seal the mortar surface where it meets the unit face.
It creates a ledge.
It creates a flat ledge or shelf, and this shelf is a perfect place for water, snow, or ice to collect and sit.
And when that trapped water freezes,
It expands. The resulting pressure causes the surface of the mortar and the unit edge to spall, leading to rapid deterioration of the joint and allowing deep moisture penetration right into the wall cavity.
we should also quickly highlight the joints that provide poor weather resistance because they either protrude or they're just not compressed at all.
Right. Any joint that extends past the face of the unit invites moisture to sit and cling there, or results in an uncompressed surface.
Right.
This includes the extruded joint, sometimes called weeping mortar, where the excess mud is just left after being squeezed out. Because it's not compressed, it's highly permeable.
Okay.
The beaded joint also protrudes, creating a defined half-round ledge. And the struck joint, which has a sloping profile that actually guides moisture toward the top of the unit below it.
So it's basically a water slide into the wall.
It ensures that the water has a direct route into the interface between the unit and the joint. Remember, the goal is always to compact the mortar surface and seal that interface to ensure longevity.
Once the primary tooling is done at thumbprint hardness, what's the final step to a flawless finish?
After the initial tooling, the heavy strike, the joint is typically tidied up. You gently brush it, often with a soft bristle brush, to eliminate the small bits of excess mortar debris that may have feathered out onto the unit face. Very carefully, so you don't smear the joint surface. Following that, a very light second tooling is often done. We call it slicking. It just refines the surface texture and ensures a final, tight seal.
Any cautions on cleaning?
Yeah, sometimes a piece of carpet or burlap is used to clean the wall after jointing, but this should only be reserved for dense, smooth surfaces like polished concrete block. If you try that on a highly textured brick face before the mortar is fully set, you risk grinding residue right into the unit texture.
And creating a permanent, ugly stain.
Exactly.
Segment 4, the mud, modernization, and the safety minute. We've talked about placing and finishing the mortar, but none of that happens without properly mixing the mud first.
Right. Mortar is the lifeblood of our trade, and consistency here is paramount.
Why is it so important?
Mortar consistency dictates structural integrity, workability, and color uniformity. Power mixers are absolutely essential for achieving the required uniformity on any commercial job.
You can't mix by hand.
Trying to mix mortar by hand with a hoe is fine for patch jobs, but anything commercial requires machinery to ensure the aggregate, cement, lime, and water are thoroughly and uniformly blended. Poor mixing leads to varying strengths and colors across the wall.
What types of mixers are the most common on Canadian sites?
We typically see three main categories. The paddle mixer is very common. It uses stationary paddles inside a drum, forcing the material through the blades.
And that's good for...
They are great for small to medium batches and are highly effective for incorporating lime and air entraining agents into the mix without overheating the cement. For large-scale commercial jobs, however, the hydraulic mixer is often preferred.
Why the hydraulic preference on big sites?
They're just generally considered the most efficient and durable for high volume. They're driven by powerful hydraulics instead of a vulnerable chain or belt drive system, so they can handle higher capacity batches with less wear and tear.
Got it. And the third type?
Standard drum mixers, which rotate the entire drum. While they're commonly used, they're actually better suited for mixing concrete than mortar, as their rotation can sometimes lead to segregation in a fine mortar mix if you run it too long.
When we talk about quality control and workability of the mud, there are specific testing instruments used, and we always aim for low slump.
Right, we aim for low slump mortar. That means it has a lower water content, greater stiffness, and superior resistance to shrinkage and cracking. To quantify this stiffness, especially for that high-volume liquid grout we discussed earlier,
Right.
we use the slump cone test.
So how does the slump cone test actually work on site?
It's a standard procedure based on ASTM or CSA standards. You fill a steel cone, a truncated cone actually, with the fresh grout in several lifts, tamping each layer meticulously.
Okay.
You strike the top smooth, lift the cone straight up, and then you measure how far the grout mass settles or slumps. A low slump indicates stiff, durable material, whereas a high slump means too much water, which compromises strength.
And for mortar consistency specifically?
For that, the flow table test is used.
Detail the flow table procedure for us, because that's the gold standard for masonry workability.
The flow table is a precision instrument. A small brass mold is filled with the mortar sample and placed on the table. The mold is removed, and then the table is mechanically dropped a specific number of times, typically 25 in a set duration.
And what does that do?
That dropping action simulates the vibration and movement the mortar experiences during placement. You then measure the diameter of the spread mortar. The resulting flow percentage dictates the mortar's workability.
So too low is bad, too high is bad.
Right. A flow that is too low means the mud is stiff and hard to spread, so you have low production. A flow that's too high means it's soupy and lacks the stiffness for structural integrity. Maintaining a tight flow range ensures uniformity and bond strength across the whole job.
And that low slump preference is what separates the pro from the amateur. It reduces shrinkage, improves durability, and crucially, supports the weight of the units above without excessive compression.
That's true. It reduces long-term maintenance.
Speaking of high standards and low expectations...
Are you going there?
I am. Why did the bricklayer break up with his girlfriend?
I don't know.
Because he thought she was a bit too high maintenance.
Right.
And he prefers his mud with a low slump.
Keeping that slump low keeps your walls high. That's the technical takeaway, regardless of your dating status.
Fair enough. Before we move on to the safety minute, let's briefly touch on site cleanliness. It's crucial for environmental compliance here in Canada.
For sure, especially regarding wet trade waste.
The slurry tub is a great, often government-mandated solution for managing wastewater.
It's essential. A slurry tub is a dedicated container system designed specifically for cleanup. It allows masons to clean their tools and capture the resulting wet trade waste, or slurry.
How does it work?
The system typically uses sedimentation or a specialized biodegradable filter. The process allows the solid cementitious waste to settle out and harden, while the relatively clear, pH-neutral water can be reused for tool washing or safely drained.
And the solid waste?
It's then legally disposed of in the site skip as solid inert material. This prevents hazardous washout water from getting into the storm drains or municipal sewer system.
Okay, let's pivot to the realities of the Canadian construction season. We don't stop just because the temperature drops.
No, we don't.
And the need for temperature control directly relates back to that critical timing of thumbprint hardness and the chemical reactions in the mortar.
Exactly. The setting of mortar is a Heideggerian process, and it requires consistent heat. Canadian masonry standards dictate that the temperature of the materials, the units, and the air around the fresh masonry must be maintained above 5 degrees Celsius during mixing and for at least 72 hours after laying.
So portable construction heaters are essential.
They're essential for extending the masonry season into late autumn and through the winter. We use methods like covering the wall with insulated blankets and tarps and heating the enclosure.
And you'll see various types of heaters being used on sites.
You'll encounter the ubiquitous propane-forced air heaters, often called salamanders. They're fast and powerful for quickly warming an area. But there's a risk.
A big one. They are fuel-fired, and they consume oxygen, meaning they need proper, continuous ventilation to prevent the buildup of deadly carbon monoxide inside the scaffold enclosure.
And there's a serious certification requirement for those fuel-fired units here.
Absolutely. Workers in Canada often require specific certification, commonly known as a propane ticket or a similar fuel handling endorsement, to operate those heaters safely and legally on a commercial site.
What are the other options?
You might also see diesel indirect space heaters. These are safer for enclosed spaces because the combustion unit stays outside the work enclosure. It only pumps heated, clean air into the work area through heavy-duty tubes.
And electric.
If electricity is abundant, portable electric forced air heaters are used. Unlike fuel-fired units, electric ones produce zero emissions and can be safely left running unattended overnight to maintain that critical curing temperature.
Controlling that temperature environment ensures the mortar sets uniformly and reaches its intended strength.
And prevents catastrophic failure from frost damage. Okay, let's wrap this deep dive with the safety minute. We're talking about heavy tools, power equipment, and cutting hard materials, which leads us to one of the biggest long-term health hazards in our trade.
Silica dust.
Silica dust.
This is a serious, lifelong health issue we have to address, frankly. The dust produced when you dry cut, brick, block, and especially concrete, contains crystalline silica.
And repeated, unprotected exposure causes silicosis.
A severe, sometimes life-threatening and incurable respiratory disease. We have strict regulations for mitigation for a reason, driven by decades of tragic history.
So mitigation is absolutely critical. What is the gold standard for managing silica dust on the job site?
Wet cutting is the non-negotiable gold standard whenever feasible. Using a masonry saw's integrated water pump system, which sprays water directly onto the diamond blade, greatly reduces the dust cloud.
It suppresses the particles.
It suppresses the respirable silica particles. And if you are wet cutting, you must protect your skin and clothing from the water, and slurry large rubber gloves, often elbow length, and a waterproof plastic apron are recommended.
Why is that so important?
To keep you dry and protected from the alkaline lime and cement in the slurry mix, which can cause chemical burns over prolonged exposure.
And when wet cutting isn't feasible, or even when you're just mixing mortar in a confined area, what is the required protection for your respiratory system?
You absolutely must wear an air purifying respirator, APR, with replaceable P100 filters.
Not just a simple disposable dust mask.
Never. A certified APR provides significantly better protection by creating a tight seal around your face.
Yeah.
Disposable dust masks often leak air around the edges, letting those dangerous respirable silica particles in.
And a critical point for that seal.
For proper fitting, especially with an APR, remember a critical requirement on most sites. A clean-shaven face is often mandatory to ensure that perfect seal.
And finally, a reminder on general PPE guidelines across the Canadian trade.
CSA-approved personal protective equipment is mandatory. Hard hat, high-vis vest, steel-toe safety boots, safety glasses, and hearing protection whenever power equipment, like quick-cut saws or jackhammers, are running. Operating a power saw requires extreme caution due to the high-speed blade and the intense risk of kickback.
So you secure your materials, maintain a strong, balanced stance, and ensure the guard is properly set.
Critical for your immediate safety, for sure.
We covered a tremendous amount of ground today, from the basic scoop of the trowel to the complex logistics of high-rise safety and cold weather tiering. Let's quickly summarize the key takeaways for you apprentices as you get back to the wall.
First, selecting the right trowel is an ergonomic decision. It impacts your lifetime efficiency and your health.
London for brick, Philadelphia for block.
Choose the London pattern for brick or the Philadelphia for block. Ensure you have a forged tang and prioritize the handle angle that keeps your wrist as straight as possible to avoid long-term strain.
Second, precision is achieved through mechanical consistency. Master the use of the story pole and the gauge tape to ensure repeatable results, eliminating guesswork.
And never forget that triple check when building a lead. Horizontal level, vertical plumb, and a straight face.
Third, the finish is your reputation and the structure's durability. You must understand the technical timing waiting for the mud to reach thumbprint hardness
to ensure maximum durability and aesthetic uniformity. And always prioritize weather-resistant sealed profiles like the concave or the V-joint over the vulnerable rake joint for exterior Canadian work.
Keep your lines tight, your joints clean, and your levels true. We'll see you on the next wall.
You know, we spent a lot of time discussing the different joint profiles and their necessity for weather resistance. The concave is the most practical, the raked is the least durable. But as you continue your apprenticeship, as you gain speed and develop your eye, start thinking about which of these classic joint profiles, the concave, the raked, or even the subtle flush or grapevine finish, often reserved for historical restoration, which one will become your signature finish. Think about not just what is required for minimum durability, but why your consistent choice of finish matters to the long-term legacy of the structure you leave behind. That final, permanent impression, it lasts for centuries.